verify that the triangles ABC, so ABC, and ABD, so ABD, are congruent. So because they're telling us to verify, this means that the triangles are definitely congruent, and we just have to prove that they are. So what does congruent mean, or congruency? Well, it means that in terms of triangles, that they are all the same size, so all the lengths are the same, and they're all the same angles. The three angles are equal. So if two triangles are congruent, they will either have three sides being equal. So SSS stands for side, 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 so the three sides will be equal. SAS, side, angle, side, so that would mean two sides are equal and the included angle, so the angle in between the two sides would also be equal. ASA, which represents angle, side, angle, so two equal angles and the side in between the two angles also the same. Or else RHS, so the R standing for a right angle, the H standing for the hypotenuse, and an S standing for the other side. Okay, so let's have a look at our two triangles. So we have ABC, ABC, and we have ABD, ABD. So what I'm going to do is I'm going to draw these out separately, and then I'm going to label them again. So drawn out separately, we have ABC, so ABC, and ABD, so ABD. So AC and AD are clearly equal because they have these little lines here which represent equal length. So AC and AD are equal. So the length of AC is equal to the length of AD. Then the length of AB is also equal to the length of AB. So AB is clearly the exact same as AB. They're the same length. So they are a common side. So they are equal to each other. And then angle ABC, so this angle here, and angle ABD, so this angle here, are the same because they're both 90 degrees. And we know that because we have the little 90-degree symbol in there, so the perpendicular angle or the right angle symbol in there. So we have a common side, we have a common hypotenuse, and we also have a right angle. So therefore, triangle ABC is congruent to triangle ABD. And this is because of RHS. So R representing the right angle, H representing the hypotenuse, and S representing the other side. Always remember to state which case you used to show congruency. So we used RHS. Is triangle PQR congruent to triangle RST? So we have triangle PQR, so this triangle here is triangle PQR. And then we have triangle RST, so RST. And we want to see, are they congruent to each other? So at this point we do not know. In the previous question we did know because they said verify. But now we're being asked, are they congruent? So let's start off with the length of QR. So QR is here, and it's labelled as 5 centimetres. And RT is here, it's also labelled as 5 centimetres. So we have an equal side. So the length of QR is equal to the length of RT. They're both 5 centimetres, so we have a common side. Okay, so then angle PQR, so PQR is 100 degrees, and angle RTS, so RTS is also 100 degrees. So we have a common angle. And then angle QRP, so QRP, so this angle in here, is equal to angle SRT, so SRT, so this angle in here. And that is because opposite angles are equal. So they are vertically opposite, so they are equal. So then we have an angle. So we have a side, an angle, and an angle. But we just have to make sure that the side is in between the two angles. So we want to have ASA, which represents angle, side, angle. And this means that the side is in between the two angles. So let's just check. So we have an angle, a side, and an angle. So that works out. And then we have an angle, a side, and an angle. So that works out as well. So therefore, triangle PQR is congruent to triangle RST. And this is because of ASA.